radian angle measure and trigonometric functions of real numbers. That's the name of the game in this section. So the goals, number one, we want to convert between radians and degrees. Number two, we want to compute the arc length of a sector of a circle. So think like the crust of a piece of pie. We want to be able to compute the length of the crust of the piece of pie. Number three, we'll solve some apps, probably not today. Number four, we'll evaluate a trig function of any real number. Again, I've broken this section up into two parts. That'll be part two. Radian angle measure. So here's the picture. So take a look at the circle on the left there. I drew a picture with what looks like a piece of pie cut out. So what we want to talk about is S, at least for now, S, which would be arc length. And you can think of it as the length of the crust of the pie. And we say from A to B, we say that the arc from A to B subtends the central angle theta. It's probably the only time you'll hear me use the word subtend in this class, but in case you see it, I wanted to write it down. Then what's the definition of radian angle measure? So bless you. The radian measure of theta is given by the arc length, which is S, and then you divide by R, right? So theta equals S divided by R. That's the definition of radian angle measure. And it wouldn't matter if you wrote R bigger for the same angle. You'd get the same angle measure because you just get a circle that's proportional to the one drawn if you made R bigger. So theta equals S over R. Now right away there's a benefit to this angle measure that you don't have with degree angle measure. Right away, you get the arc length formula from this definition. Does anybody see why? So if you wanted to find the length of that piece of pie, the crust on that piece of pie, that is, how could you manipulate that formula algebraically to get S? Yeah?
S equals theta times R?
Yeah. So S, if you just multiply both sides by R, S equals, usually it's written R times theta, but it doesn't matter. Theta times R, R times theta. And then this is your arc length formula. So you have to memorize either the definition of radian angle measure or the arc length formula, and you can come up with the other one. So in other words, if you remember S equals R times theta, theta has to be in radians. And if you divide both sides by R, you get S over R. You get theta equals S over R, which is the definition of radian angle measure. So either way you remember, you only have to remember one formula. You get 2 for 1. What a deal. 2 for 1. Okay, so the other big note is we're going to want to know how to convert between radian angle measure and degree angle measure because there's going to be situations where you have to do that. So if we went all the way around, so in other words, you eat the whole pie. Pie. So instead of having a piece of pie that looks like this, you go all the way around. So then your arc length is here. Instead of that, you go all the way around. So you make the angle, I'm making the angle bigger, right? The angle of the point of your pie bigger. You go all the way around so that we're talking the length of the crust of the pie is the entire crust because you're eating the entire pie. So the angle measure in degrees is 360 degrees. If we know the angle is 360 degrees, how can we find the angle in radians? So S is the entire crust of the pie. The entire circumference is another word to use here, right? And don't we know a formula for circumference? Yeah, so in this situation, it's 2 pi r. S is circumference, which is 2 pi r. R is the radius once again. Would you buy that? Okay. So let's think about the formula we developed for arc length, radian angle measure. Let's back up even further to radian angle measure. So in radians, theta equals S over R. But we know that in this particular example, when we're eating the whole pie and we're trying to get a stomach ache, S is equal to 2 pi r. So I'm going to make that substitution there. Everybody see that? So I'm going to say then, S is equal to 2 pi, theta, is equal to S over R, but S is equal to 2 pi r, so I'm making that substitution there. And then what happens to the r's? So does the size of the circle make any difference whatsoever? No, because the r's, because we're dealing with proportional objects here, the r's are going to cancel. And we get theta is equal to 2 pi. But wait a minute, the assumption was theta in degrees is 360. So what does that mean? 2 pi must equal 360 degrees. But wait, there's more. I feel like I'm selling you a radian angle measure here. We could divide, this is a little equation, right? Couldn't we divide both sides by 2 to get a better equivalence? So if we divide both sides by 2, what does pi radians equal in degrees? 180. So normally we don't write down the units for radians. We call it a unitless measure. But sometimes it's helpful to be very specific. So pi radians equals 180 degrees. Okay, that's the relationship that we needed to develop. And you guys all knew that, but I wanted to make sure that you knew why. Because oftentimes you forget the details, right? Now, I also want to point out that this little equation, pi radians equals 180 degrees, well, it's more than an equation, right? Usually when you talk about an equation, you think there's certain solutions, but it's identically true, right? It's like saying 2 equals 2. It's always true, right? This little relationship here gives us 2 conversion equations, 2 conversion factors, if you like. So if I divided both sides by pi radians, I get 1. So imagine dividing both sides. So really dividing both sides by pi radians. I get on the left side 1 equals 180 degrees divided by pi. Pi radians, but again, we don't normally write down the radians, so I'm going to leave it off in this step. So 180 degrees divided by pi is just the number 1, right? But you could have done it the other way around and divided both sides by 180 degrees. Or since this is just equal to 1, you could just flip it and it'll be the same value. And you could say pi divided by 180 is equal to 1 also. So why do we care about ratios like this that are just equal to 1? Well, anytime you get a ratio like that, it's a conversion factor, and you can use it to convert from radians to degrees or vice versa. And I'll show you, if you've never seen it before, I'll show you a cool trick for remembering which one you use. So these are 2 conversion factors. Here's one, here's the other. Okay, so these are your conversion factors. That's the big idea. Conversion factors.